I was thinking about flywheels and throwing things, and I started to wonder if it were possible to make a massive flywheel and, well, use it to throw things. And yeah, this is going to be the third out of four now about or related to space, but I can't help myself. It's the perfect simplification. You don't need to worry about pesky things like air resistance or gravity or reality getting in the way. Essentially, the idea was that if you let go of a spinning thing, you go flying. So maybe you want a bit of a boost from low Earth orbit, so you dock at the center of a massive spinning space station and take an elevator, I guess, up to the top, and then you get flown from the top and get a little extra velocity from it. And this could go the other way as well. If you're coming back to Earth, you could get caught by the space station and brought back down to the middle. This would have the added benefit of counteracting any loss of spin. When you move up to the edge, you're not gaining velocity for nothing. That's impossible. The velocity that you gain comes from the station itself, meaning that the station slows down. It's like if you spin in a chair and spread your arms out, it makes you slow down. The advantage of catching things on the way back is that it has an opposite effect. The object that's been caught doesn't lose velocity for nothing. It makes the station speed up, like bringing your arms in a spinning chair. So, is this feasible? Well, no, not really. Spinning makes you experience acceleration, like how making a sharp turn in a car pushes you to the side. That means that if we want to have humans use this machine, it can't be spinning too fast. Acceleration in a circle is given by this formula, and as we'll see, that v squared is quite annoying. That means that if we want to try to keep our acceleration down, we need a very big circle. Now, the first thing that I tried to calculate was how big our space station would need to be in order to achieve Earth escape velocity, since that would be an ideal application. And, well, here's the Earth, and here's our station. So that's obviously not going to work, and getting to the moon is really no better, so what can we do? Well, let's say we want to fix the radius of the station at 1 kilometer, which is already a stretch, but at least it's more feasible. Well, if we want a nice, comfortable 1g of acceleration, we can only get about 100 meters per second of a boost. Not much, since that's about 1% of escape velocity. Even if we stretch it to 2g's of acceleration, which is probably more than a human should be taking for an extended time, it only gets us up to about 140 meters a second. That's because of that pesky square root. If we want to double our velocity, we need to quadruple the acceleration we take or the size of the station. Even if we stretch it beyond human capabilities, say for cargo, 10 Gs only gets about 300 meters per second, and 50 only gets 700. And at this point, you need some pretty sturdy cargo to be able to survive that. Not to mention, building a space station that's 2 kilometers across in the first place.